Hello and welcome to the Let's Talk Azure podcast with your hosts, Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Office 365 focused IT security professionals. Each episode, we talk about a specific topic in the space. This week, it's episode 19 of season 3. We're going to have a chat around Azure DevOps, a suite of tools to enable effective development practices and modern collaboration for software teams. Hey, Alan, how are you doing this week?
Hey Sam, not doing too bad. It's been a short-ish week, but busy. It kind of feels like doing 5 days in four.
Yeah, we've had double back-to-back bank holidays, haven't we? It's been it's been
Yes.
good, but also, yeah, on the other side of it, like you say, compressing 5 days worth of it seems into four, right? Definitely.
Yeah, definitely. Yeah, we've been doing quite a lot, haven't we? So
Especially when you're sort of talking to people in other parts of the world that don't have, bank holidays as well, right?
yes.
It's business as usual over there. So yeah, it's definitely catch up for sure. So yeah, this week we're gonna have a chat around Azure DevOps. I'm sort of going to lead the. Alan's going to ask me questions. I'm sort of going to lead the answers, but I think it's fair to say that Alan spends nowadays just as much time in DevOps as I do. So he's definitely
Parts of it, yeah, parts
yeah,
of it, probably not the whole thing. Yeah.
yeah. So I suppose I've got a bit more knowledge from the development side, but Alan is definitely a power
But
user of DevOps,
last
arguably.
6 months in it,
Yeah,
probably. Yeah.
definitely. Cool.
Um, cool. Right then. So let's kick off. So what is Azure DevOps aiming to do?
Okay, so I think the first thing I want to just sort of explain is that I kind of don't agree with the name, right? And that's a bit of a weird. It does make sense, but because of what DevOps is, like continuous integration and continuous delivery, it almost makes it sound like it's just a tool for DevOps practitioners. When really what it is it's a collection of sort of developer orientated tooling. So in its name, sort of develop. If you take it as sort of like developer operations, it makes sense as well. Because you've got collaboration tools to basically help you to build effective software in a more modern way, should I say? Um, so if you're used to other development platforms such as Jira, GitLab, GitHub, um, you you can think about it as Microsoft's version of those product toolings. It's obviously got a bit different recently because of Microsoft's acquisition of GitHub, so they're more tightly coupled than they've ever been, really. So we'll talk about that in a bit more depth, but effectively what DevOps is aiming to do is give you the tools to build and ship mainly software projects. But we'll talk about that. There's actually tooling in here that goes way beyond software products, and maybe we'll talk about some of that as well. So it helps you to build and ship your code faster, but also it enables you to collaborate with your teams as well and to do testing. So it's not just purely development focused; it's also project management focused, stakeholder focused, testing and UAT focused. So it really is a collection of different tools, an ecosystem, a platform, if you will.
Okay, so it's not just about DevOps. It's all about potentially project management and that whole development suite that you said around some of those other products. So it's a bit more than just solely DevOps. So okay,
Yeah.
so what are some of the features in DevOps then that make build make that sort of product suite?
Okay, so there's sort of six main areas that I'm going to. I'll jump into a bit more depth on each one, but I'll just sort of call it out each area now. The first one is boards, which is imagine your project management system. So if you're used to a Jira or Asana or something of that nature, that's what boards is for. I'll jump into boards in a bit more depth later. Um, Azure repositories. So this is Git and TFS hosting. So a place for you to store your code and to collaborate on that code. Think GitHub in that regard. Um, we've got Azure DevOps Pipelines, which is probably the closest thing to DevOps that's there. Pipelines is the ability to automate the build and deployment of your code. So if you're using things like GitHub Actions, GitLab, um, I can't remember what it's called on the Atlassian side, Bitbucket Pipelines. Is it? I can't remember, but there's a Bitbucket product as well. Um, so there's many different other sort of separate products out there to do DevOps. Um, but if you're currently using something like that, you're going to feel very at home with pipelines. Then we've got test plans. Test plans is all around both manual and automated testing. So it's really an area to plan your testing strategy and to gain feedback. We've got artifacts. So when you when you build your software, you might go ahead straight away and deploy it. So to say some sort of production environment, um, or you might, your output might actually be some sort of artifact. Maybe your development is building some sort of library or package or plugin that's then consumed by somewhere else. So artifacts gives you the ability to publish your build output as artifacts and turn them into feeds so people can consume them. And the last area that I'm going to talk about is DevOps Server. So if you've used previous Team Foundation like on-prem infrastructure, this is the replacement for that. So if we take Azure DevOps is a sort of cloud-hosted Microsoft, it's a SaaS platform that you could just use and consume. DevOps Server is an on-premise hosted version of that. So I'll talk through some of the benefits of that.
Okay, cool. Anything else?
I suppose there's also some sort of overarching features and functionality that I suppose I should call out at this point. There's also dashboards and wikis that you can create. They don't sit technically inside of any of those areas, um, but the dashboards allow you to report across all your projects and everything that's going on. And the wiki allows you to build wikis of knowledge databases for your software as well. It's usually for internal documentation of what you're building.
Okay, brilliant. I mean, there sounds like quite a lot there, and not necessarily coming from a DevOps or a development background. It sounds like quite a few key sort of features I kind of imagine would be in developing software.
Yeah,
Uh,
yeah. I think if you're used to like the full Atlassian suite, if you're a Bitbucket, a Jira, and all the product suite there. If you're using GitLab, they've got a fully integrated sort of development environment. This is uh, not feature equal, but this is the same thing in Microsoft's ecosystem.
okay, brilliant. So you mentioned the Azure boards. Can you give us an overview of what they are and what they, how you use them?
Okay, so um, sort of starting from an entry point, it's a way to track work items and the progress against those work items. So let's say you have a requirement that comes in that the red button must now be green. You could log that requirement or work item in the system, and you could track its progress. You could give it documentation, describe what needs to be done, um, attach governance and justification of why that change was made, assign it to an engineer to action, track as that engineer actually makes that change, even in the code as well, and then push that through to testing as well, and make sure that your test plans have been um, followed along that. Um, there's lots of different software sort of methodologies. So you've got things like more agile processes like Scrum, more sort of basic Kanban, um, and also CMMI. Not so widely used more widely used, I would say, in the enterprise. But what Azure Boards has is the concept of processes, And a process is effectively the workflow that a work item will go through. So you could say that, a work item has got three different states. It's got to do, in progress, and then done. You can decide as that work item progresses through that workflow what the different gates are and the checks are. For instance, like you could say a work item can't just go from to do to done because that doesn't make sense. It must have been worked on if it was done. Maybe you would add a fourth state in, which is, rejected. So, maybe it's to do, it's on your backlog, and then there was a business change, and you decided that you didn't need to make that. You might want to classify those as not implemented or rejected, or put back on a backlog at that point. So those processes out of the box, there's a few that you get, maybe around more agile and iterative development processes, but you can actually go in and customize those processes as well. So if you've got extra states, so for instance, I've worked in development teams where they've added more states in because they've got QA in between. So they might say, it's gone from to do, in progress, on staging, then it's gone to QA verified, or QA rejected, and then it goes back to the engine. So you get that full. If there's 3 or 4 people, and this is inside the team, this is before we get to external UAT. Just as you go through that development cycle, you can map out all of your different stages and gates that you want to. So you can base it on you could base it on a Scrum template if you want. They've got one of those inbuilt, but you can customize it as well, and that's even possible in the cloud version as well. I sort of so once you're working on your work items, you can put them into boards. So boards are like, if you've ever used any Kanban style of boards, thinking a big one is Trello, that a lot of people may have heard of, where you've got columns with cards in it. So there is a Kanban focused view that you can use if you wish, and that's effectively your different states that you would take your work items through. There's also backlogs and sprints. You might not call your sprints, you might call them iterations. It really depends on the terminology that you use. But effectively, think that as, we'll take these 10 requirements, we'll bundle them up into a sprint, and we'll work on those. Or it might be 5, or you might have a time based sprint. You might just say, we'll try and complete as much as we can in a 2-week period that we think is reasonable, and then push that out as a sprint of work. So you can set up iterations or sprints, iterations, and manage it from taking items from your backlog and then planning them out in sprints. You can then use the dashboarding that I talked about in the reporting to basically build graphs. So you can get your burn down graph. You would say that if you've got X number of story points, let's say you had 7 story points to complete over a 7-week sprint, you want to complete 1 a day in theory. So you could plot that on a burn down. There's many other different charts that you can see there. You can track how much effort has been made. You can estimate effort, and then you can track against the actual effort that was burned on it to see if you're slipping and keep control of your project in quite a detailed way. There's also the concept of custom queries, so that what you can do is you can say, okay, like Alan's on my development team. What's Alan got in his that's assigned to Alan, and what has he got left to complete? Is Alan slipping on some of the items that he's working on? Does he need extra help to come in and help that? Has the whole team, misidentified the effort that's required in order to do that? So it's really about having that visibility, and once you have that visibility and that control, because once you have that visibility, it's really important then to be able to act on it. Without that visibility, you can sometimes get to the end of a sprint and go, what have we actually achieved? And non-technical stakeholders might go, well, you had 15 things to do, but you only managed to do 7. And sometimes that's completely legitimate. Things come out of the woodwork, spanners get thrown, You know, that's just what happens. So as you're going through that progress, keeping everybody up to date is really important, because 9 times out of 10, it's not a it's something that nobody's seen in the team. So once you have that collaboration, it's not just on one person's responsibility to make sure those work items get out of the door.
Wow. Okay. So that, I mean, there's absolutely tons there, isn't there, to think about. And when you talk about Trello and things like that from the Kanban perspective, I was thinking of Planner from the Microsoft side,
Yep.
equivalent, technical, well, yeah, as equivalent as it can be. Um, and yeah, so it sort of recap that, I guess, or my view of that is, it's potentially helping with project management. You've got those processes, templates you talked about. Um, to in effect to choose which type of that process you want to run through. You're able to put your work items in there that potentially could be new features, changes to the code that needs to happen because there's a like we're talking, there may be a process overrunning or something like that, maybe that just needs to be rectified. um, and yeah, then there's a load of reporting and managing the sprints or iterations, etc. So yeah, it seems really good, and we've used it a little bit, haven't we, in our day to day,
Yeah,
trying
and
to track some of the stuff that we miss.
yeah, definitely. And I think, for me, when I've worked in actual development teams, um, I'll call it like detailed project management, like work item tracking is
Hmm.
day and day, right? Like it's when you're in a development team as an engineer, you'll just have a list of your backlog, and the project managers and the product team will just make sure that you have a never-ended list of stuff to do. So you open your IDE in the morning and you work on you just got a list, a prioritized list that you work through, right? In our world, it's a bit different. It doesn't. There's not that level, usually that level of complexity that's required as well for that, real
Yeah.
detailed and granular tracking. But what also I just wanted to call out as well is that there are project process templates in DevOps for you to track non-technical items as well, things like new ideas that come in, new requirements that you might put through a process before they actually become an item. You can track risks that are, if you're working in a team that has to maintain a RAID log, you can track risks inside the system and sort of bring that RAID log actually closer to your delivery team as well, because then everybody has visibility of that who's collaborating on it. And it's also you have the ability to bring in non-technical stakeholders as well to look at that dashboarding and that reporting. So think about this as like Power BI for your project. If you've got a non-technical stakeholder who doesn't really need to be in the detail, but they want to understand, you know, what their RAG status is on their the sprint burn down, then that's available to you as well, instead of having to like update an Excel sheet and send it round to everybody. It's driven from the actual work items themselves. Everybody's aware and everybody can access it whenever they like because it's a sort of an open process.
Okay, brilliant. Yeah, that definitely sounds like a powerful feature, and we're not even sort of talking DevOps here, as in the process.
Yeah,
um,
yeah, exactly. Yeah.
okay, so how about Azure repos then?
Okay, so yeah, if you're currently utilizing Git or TFS for your code repositories, um, I mean, I would I don't know. That's probably not the right thing to say, but I would say probably the most popular version control system currently today is Git. That's why it features prominently within Azure DevOps, and you get a Git web user interface. Think GitHub or GitLab or Bitbucket. So you have the ability to manage your branches, manage your pull requests, manage access for team members. And what's great is that you can have multiple code repositories per project inside of DevOps as well. So if you've got maybe you may have split your project into multiple code repositories. They can sit all under one project if you wish as well, and you can track across all of them. So it's not like a separate Git repo for each project, and project boards are separate or anything like that, which is really nice. I kind of mentioned pull requests. So you have the very similar to GitHub and Bitbucket. You have the ability to open a pull request, and there's a whole review process and triggering of CI/CD pipelines and verifications and validations. So if you're used to um, building like a pull request process and a CI/CD process within, say, GitHub with GitHub Actions, this is very similar on this side as well. It's also got sort of grown up. What's the best way to describe it is protections and policies in place. So, for instance, some teams protect their main branch and their develop or staging branches to stop people committing directly to those branches. So you can say things like, in order to deploy to the main branch, which is your production branch, you have to go through pull request approval. Then you can say, two members of the team, or one other engineer and also a QA needs to sign it off. And a modern collaborative sort of development approach is where you build in the open. You open a pull request, and that's basically like, if I'd done some updates, I'll make a separate branch, a copy of the code effectively. I'll make my changes. I'll open a pull request and I'll say, hey, Alan, can you check my code for me? Because Alan may, doesn't even matter if Alan is more senior than me or more experienced. Alan can also, look at that code and can say, hey, Sam, it might actually be better to approach it from this way. So in a lot of times in development teams, you'll have a buddy system where you'll be buddied together with somebody, or the whole team might just be collaborative and they might just pick them up. And what we tend to find with a modern collaborative development approach is, we don't, in the teams that I've worked in, we don't get people going, oh, you've named that wrong, or you've indented that incorrectly, or more opinion based or preference based changes. It's more around people's understanding of the problem or the business that drives it. Because let's say I've just joined the payments team, and Alan built the payment system from the ground up because he's been in the organization from day zero. Then it might be worth getting Alan's input on whether our latest changes are going to meet all of the requirements, and also many of the other requirements, or that we don't know about, if that makes sense. Because some of these software systems can be really large and complex, and it's impossible to even understand all of the areas of the code base as well. So getting more people involved as soon as possible leads to higher quality software for the long run. And at the end of the day, we're here for the business and for our end users and or customers. The most important thing from a product team perspective is that we've checked and tested everything before it's even hit any sort of staging or production environment, to make that feedback loop as short as possible for things to go live.
Cool. Yeah, I mean, we use it quite a lot, don't we? And yeah, you can see how code review is great. I mean, it's probably fairly standard within the development world anyway. But also it's
Yeah,
probably
I
worth.
wouldn't. I suppose it's probably worth calling out that um, it when we say standard, I think across the board, I think it's well accepted of the benefits of it. Um, but in terms of sort of a tightly defined a tightly defined process that is controlled like that, that is quite a mature process even today.
Okay.
Because as much as technology has helped us to improve that collaboration, it's also helped us to streamline and go around that. Because without branch protection, how easy it is just to push some code onto the main branch, right? All you got to do is just merge your, you
Yeah.
know, you can even do it locally and then push it up, right? Um, so we want to give teams the ability to have those operational efficiencies, but we've got to govern it in the right way because even I've been guilty of that in the past. You've got a looming deadline and you've got this high priority bug. It's like a 2-second fix. Oh, I'll just deploy that to production. Um, that's when you need these protections in place because it's everybody's got the best intentions, but at the end of the day, it might just be worth taking a step back and checking things. So open collaborative processes is the way to go moving forward.
That's cool. And I was just going to say about sort of an added bit to the pull request side of it is that when that happens as part of it might even come into the pipelines, which we'll talk about in a minute. But the new Defender for DevOps now will annotate or comment about any of your code maybe being less secure, maybe let's say vulnerable, or it will tell you, give you some advice on it at least as part of that process now. So that's
Yeah,
really good.
yeah, exactly. And it is probably worth talking about that now because the um, the pipeline runners are usually triggered by a pull request, and as you've mentioned, you can have processes that check and test. Like for instance, with your example, it's um, a security benchmark and check. You can have other tools like I've used tools in the past for code quality. We all agree what our naming convention could be. So we let a robot just, basically say, "Hey, Alan, you've written that wrong, right?" And that completely takes the humans out of it because if it's passed the robot test, then nobody needs to talk about capitalization or indenting with tabs or spaces. Like we don't need to have that conversation um, in DevOps. But as you've mentioned, there is that modern approach to pull requests, verification of those pull requests, and gating there to say, okay, the automated processes have run, everything looks good. So before even a human's even got to the pull request, you would hope that those automated processes have run. You jump into my report request to review it. You can see the changes. You could even check out the changes and run them locally if you want. And you can also see the results of those automated processes running. And that gives you, as the reviewer, as much support as possible to make the correct judgment about whether you would approve that change moving forward.
Yeah, it gives you context, doesn't it, as well? And yeah, like you said, extra visibility of something's checked. Check the code. At the time, it looks from a security perspective, because I'm always coming from that side. It looks good, kind of thing. So
Yeah, because if you imagine, right, you do an update to a React app, and that React app might have 100 different dependencies,
mhm.
right? And you might have just gone in to change the red button to green, right? And in the time since the last deployment, let's say the last deployment was a month ago, right? And you're coming in a month's time. You go to you go to push a new version unknowingly because you're not even editing that part. One of the packages has got a severe or critical CVE in that time. Defender for DevOps is then going to kick in and go, "Hey, Alan, by the way, your uh, insert random JavaScript package has now got a critical CVE. I'd like you to, bump up to the latest minor version of that before you can proceed." You know that type of notification. That's the sort of things that just completely get missed
Yeah,
because unless you have like a process or an OA to go and check that, and it's somebody's job once every week or 2 weeks or whatever to go and bump the packages and make sure that there's good coverage there of there's good protection there against new CVEs and vulnerabilities that have been discovered. That is immensely powerful. It's constantly looking, it's constantly checking. doesn't rely on a human. Some stuff we should rely on humans. I'm not saying automate everything, right? But in this mind-numbing task that is still very important, these are the sort of things that get missed, and these are the gaps that then serve us into. We will definitely do an episode dedicated for Defender for DevOps, because it's not really just Defender for DevOps. There's other security related uh, processes and procedures that should go on there for secure development for sure.
Yeah, so yeah, maybe an episode on secure development slash DevOps security, including Defender
Yeah,
for DevOps. Yeah,
yeah, because there's shared responsibility that comes into it. There's you know the attack surface is just insane with custom development compared to other things. So yeah, we'll do an episode on that.
okay, cool. So we kind of talked about the pipelines. So what they aim to do is, I think this is mainly the CI/CD part, isn't it?
Yep. So if your organization is using CI/CD, pipelines is what you would use here for that. You create under the hood, it's a YAML file, but you still do edit the YAML file in the web interface, but there is there's like helpers to add action steps in for you. There's a library of action steps and also extensions. I'll quickly mention extensions now, actually. There's an extension marketplace. So I'll use the example of Terraform. So if your pipeline is deploying maybe some Terraform infrastructure for you, that is what we use pipelines for. Um, there is a Terraform extension which gives you things like it will install, as the pipeline runs, it will install the Terraform binaries for you, and it will give you quick actions in order to run the various Terraform commands. So the first thing you might do is a Terraform plan. I know you might you init your Terraform, you plan, and then you apply. So you basically add in an extension to help you map all of that out, and that makes things really uh, really quick to. And other CI/CD platforms do a very similar thing, but I think what's probably good to call out is because there is this GitHub is very close. Well, it is Microsoft now, so there's an overlap of features and functionality here. But Azure DevOps was very well matured, especially in the pipeline space, way before the GitHub acquisition. DevOps and pipelines was a completely standalone product before that. Um, so yeah, you effectively build a YAML file, and you put actions inside of it. You sort of say what operating system you want to run it on. So you can do things like Linux, Windows. I think you could do Mac as well, if I remember rightly. I think there's a Mac pipeline, I believe. Don't quote me on that, might not be. But you basically say the environment that you want to run it in. So you might say like the latest version of Ubuntu, that's what we want to build on. That's also great as well, because if you're using those Microsoft hosted runners, you don't do anything. You just let them run it for you. You can also run your own runners on your own infrastructure if you want. So if you want to put some extra horsepower behind it, maybe you've got some spare capacity on prem, you can install the agent and run a runner locally, and then connect it to your cloud service as well, and it will handle sending the code down, running all the commands, and then and running the pipelines for you. What a really nice feature of it is that you can do what's called strategies, which allows you to build on multiple OSs at the same time. So you can have one pipeline. So let's say you had a cross-platform application that you wanted to build for, let's say, Windows and Linux for the moment. You could build a strategy and say, I want to build on the latest version of Windows and the latest version of Ubuntu, and it would build on both of those platforms at the same time, but running the same steps. And you can do some sort of control statements to only do certain things on certain platforms and different environment variables and things like that. You can also run tests as well as part of it. So what you may have in a pipeline as you have, you might have an initial, um, if you're deploying code, you might test it first. You might do static analysis on it. You might do some security analysis on it. Then you might go for a build. So you can basically mix and match the types of actions that you run, um, and really, it's up to you what you build in that, because you do just have, let's say, an Ubuntu instance, so you can install your own dependencies in order to do your builds. It's quite flexible from that perspective. Um, so I'm not going to really dive too deep into pipelines, but if you are currently using CI/CD, um, it's very feature complete in terms of the software that is supported and the environments in which you can run it on, both in the cloud and on premise as well, if you wish.
Okay, cool. So yeah, so what are let's think about the next thing. So test plans. Yeah, what are they, or what is it?
Okay, so the bane of a lot of development teams, testing. So I suppose it's probably first good for me to give you a bit of background on Microsoft in general in terms of development. If you imagine that Microsoft technologies, like things like the .NET framework, um, I would say they were always more geared around the enterprise, right? Um, you know, there are some .NET like open source projects, things like Umbraco and different development projects that are out there. But a lot of .NET developers are enterprise application, business application development. That's kind of my background as well. Um, so inside of the full Visual Studio, we've always had testing, the ability to do unit tested, automated testing, and that's been in many different places. But Microsoft have always really well catered for that full development lifecycle for enterprise application development. And other people do it as well, but I'm just calling out that Microsoft approaches it, I believe, from an enterprise first sort of from their side. And what test plans is really is it's the way for you to build, literally build your test plans that you're going to run through. So to start off with, you can just build manual test plans. So at the moment, you might be building test plans in a Google Sheet or a Excel, workbook of the steps that you want to go through, and then or you might have put it in a wiki or something like that. What you can do with Azure test plans is you can build your test plans in there. You can assign it to people, and then you can track record the actual run of that test that you did in the real world. Capture all the feedback and store it there directly from those interfaces. You can raise bugs, you can link into the test plan notes, and it's all highly integrated with Azure boards at that point. You can also track feedback as well. So as people, like maybe you've got a QA engineer and they are actually testing your software, you can track their feedback and the artifacts that they've produced from their testing as well. You can report on the progress of the test plans as they're run through, and also the status of them. So how green are your test plans? Even your manual ones. I think probably what is even more popular in today's world is automated testing. So if you do things like unit testing, integration testing, sometimes called black box testing, you might use chaos testing. There's many different things. Mutation test. There's very different ways to automatically test software. But you can use with supported libraries, you can run automated tests in the cloud as well as part of your testing plans. And you can also do sort of web UI testing with Selenium. So in those scenarios, you might build your software automatically with your pipelines, and you might run an automated UI test as well. Um, that also allows you to not actually do some of that testing inside of your pipelines, which a lot of people do as well. It's also sort of carved out into its own section as well with test plans, because it also links to your wider testing strategy. It's not just development testing. We're also talking about manual testing by QA engineers. And you want all of the results of that to feed into to one thing.
Okay, great. I mean, there's just so much in this product. Even just talking about these small sections will seem
It,
that seems like small sections.
it reminds me of Defender for Cloud, right? Where it's like, oh, that's just one product, and then you open it up, it's like, oh, it's 15 different things
Yes.
in one thing. Yeah. So that's why I'm not going too deep in each one of them. I just want to give you the
Yeah.
key features, the value benefits, and why how you can convince the higher ups to buy you some licenses, if that makes sense.
Cool, cool, cool. So, okay, so um, Azure artifacts, they seem quite interesting. Yeah, what are they?
Okay, so development teams will build um, literal software artifacts that can be consumed by other people. So, if you've ever used JavaScript, you might have heard of npm and npm packages. Npm packages are effectively um, sort of bundled JavaScript code that gives you the ability to do different things in your own application. So you could basically say, so there's plugins to convert date and times across time zones, because that is a complicated thing to do, right? User A is in one time zone, user B is in another time zone. What's the date difference between them? That can get complex, especially with different standards of right, it's horrible. So really lovely open source developers produce npm packages. So they build open source software, they publish them on npm, and then people can use them in their applications. They're licensed, but generally they're especially if you're just consuming them and not changing them, they're usually really permissive licenses. Now, if you're if you're building custom software, you might decide that you want to build an npm package for your core business logic. Maybe you've got a really complex calculation that's only bespoke to your business, and you've got multiple systems inside your organization that might need to use that business logic. You might decide to package it up. So if you're using .NET, you would want to build a NuGet package. If you're using JavaScript, you might want to build an npm package. If you're using Java, sorry, you may want a Maven package, and so on and so forth. Now, you can go to npm and you can buy a private npm. I think it's called a repository, but effectively, what that allows you to do is your developers to connect to npm to download modules from npm, but without anybody else being able to do it. So you can publish your own sort of like feed of different modules, and that's okay. But again, it's another like ecosystem. It's another cost. It's another extension outside of your ecosystem, if that makes sense, right? So what Azure Artifacts does is it allows you to build things like NuGet packages, npm packages, Python packages, Maven packages, and you can build feeds inside your organization. So Alan is the time zone calculator guy. I'll just use that example. And Alan's responsibility is to make sure all the time zone conversion is done correctly in the organization. So Alan builds, and let's say we're .NET developers. Alan builds a NuGet package for that, and then let's say I'm a consumer of that. I can then use that NuGet package in my .NET application. Then Alan wants to update his code because I'm not going to say there's a new time zone. Let's pretend there's a new time zone. Mars is now in scope, just not just Earth, right? So Alan then creates a new NuGet package for that with a new version. I can decide when I migrate to that new package because in NuGet there's a different version of each one of his packages. So Alan could write his code, use DevOps boards and repos to then push his code in. He could use pipelines to build it, and then he could use Azure artifacts, which are highly integrated with Azure pipelines, by the way, to store the artifacts and to build that NuGet package. So from Alan writing his code to somebody reviewing it, to actually going into the NuGet feed so I can consume it can now be fully automated. So there's no zipping, uploading to a share or something like that. It's all just completely integrated into these systems. You can also have upstream feeds as well. So you can have like feeds of feeds. I won't really go into that, but that is supported. And that's quite a powerful feature because you can have many different teams feeding in and other packages. So you could also say that you could block public NuGet and you could only allow certain packages into your private feeds. So you can control inside the organization what even open source packages have been verified. And as I've mentioned, really tightly integrated with Azure pipelines. So there's actions in pipelines that allow you to publish to Azure artifacts once you're completed. It can also, I haven't used this before, but it can also host your symbol files. So when you build software, you strip the debug symbols out of it so that somebody can't attach a debugger to it effectively. Um, but what you might want to do is you might want to actually debug one of your production builds because you might have a bug that is only seen in production. You can use those simple files to inject into your debugger, and then your debugger will understand that production build, even though it's maybe been obfuscated as it's come out the other side. So there is also a symbol file like hosting service in there as well, because those symbol files, again, bit of a nightmare to track because you'll make your production build. It'll also give you some symbol files, and you're like, what should I do with those symbol files? Should I go back and commit them to the Git repo? What's the right place for them? So that's another thing well, it's not it's for all applications really. Yeah, I was going to say it's only for desktop. It's not desktop applications. All applications have symbol files, but there's also that to manage and track as well, which it does do.
Okay, great. So moving on to the next sort of section, you mentioned about on-premise sort of solutions and the Azure DevOps Server. Can you give us a quick overview on that?
Yep. So this is Azure DevOps Services, as I think is the full name. So it's the cloud service that Microsoft manages for you. You can still, as I mentioned before, you can still connect your on-prem um, work runners into online as well. But Azure DevOps Server is all of, well, the vast majority of these features actually. The vast majority of these features, but hosted inside of your network. Um, the data stays in your network. So if you are in a highly regulated industry and you need it to stay on prem, maybe you're highly sensitive as well. What can sometimes happen is you don't have the tooling on prem for that. There are solutions. You can get GitHub Enterprise. You can get Jira. There's other tooling out there to do it. So Microsoft's also supporting that. If you've ever used Visual Studio Teams services, which is basically Teams Foundation server, which was that's like an on-premise TFS a code hosting solution that had other services in it as well. This is the replacement for that if you're using it. You can do Active Directory integration with it as well on-prem, and it's SQL Server backend. So if you want to do your reporting in SQL Server, you can do that as well on-prem. That's one of the bigger sort of because what you'll sometimes have is in larger organizations you'll feed the information about the build server into a completely segregated system, maybe even proprietary systems. So the reporting services can be more helpful to you there.
Okay, cool. So you kind of talked about access control for sort of on-premise. What about in the cloud?
Okay, so there's a full sort of RBAC model inside of Azure DevOps Services, where you can have granular control. It is very extensive about who can see what people can you can chop up the projects and the different areas of each project um, really nicely inside of that, and it can also be directly integrated with Azure Active Directory. So from an authentication perspective, um, you know your your identities kind of basically flow in from Azure Active Directory. Um, you can create sort of global permission structures, and then you can have those just automatically feed down to the projects, and then you can even override them at the project level to get like full granular permission structure. I won't go into all of it because it can get a bit crazy, but effectively, because software development, the process of software development is so sensitive anyway. That's quite well respected in Azure DevOps, I'd say. There is a lot of different configuration, and it's we're talking about maybe access control, like RBAC, but also code controls. You know, who can see what they can do
Mm.
with code. You know, can they export it? Can they clone it down? All of those different Git sort of access control mechanisms as well are also supported very nicely.
Okay, cool. And I think if I remember, you can also invite B2B guests into there as well. I think I've done that previously, so that you can have third parties come in and do like have their RBAC model in there and do their piece of code or development.
Yeah, that's what I
Okay,
believe. Yeah.
cool. Okay, so the suite sounds amazing. There is tons and tons in there. How much does it cost?
Okay. So there's quite a few different ways and different types of users, and there's also different types of services, and so there is a bit of a matrix going on here, right? Because it's not there's not just like three SKUs and you just decide which one. I'll start off with open source. Okay. So for open source, you can get so for public repositories, you can get free parallel jobs for public projects. So you can have 10 parallel pipeline projects, parallel jobs, sorry, for public projects running there. And you can also then layer on. So if you want to just do pipelines, you can have that as well, or you can then opt in for actual DevOps, and that is then really covered in. It's kind of the same with the free tier. Really, you get 5 users for free to start off with, which is very similar to things like Bitbucket and other solutions. Um, so that gives you your pipelines, your boards, your repos, your artifacts, your test plans. And then on top of that, you can pay $6 a month per user if you want to build in private at that point as well. Um, the vast majority of Microsoft ecosystems developers may probably be under Visual Studio, like MSDN, Visual Studio licensing. So so dependent on your Visual Studio subscription, you get different access to DevOps and also different levels of consumption that you can do inside of there. I'm not going to really jump into that because I mainly want to talk about the different types of users as well in DevOps, because what can sometimes trip up a lot of development platforms is how much you've got to pay per user. Now, this sometimes gets a bit tricky because you might have like non-technical stakeholders. Maybe you've got a head of or something like that needs access to things like dashboards and things like that, but they don't build software. They're not project managers. They're not product managers. They're not QAs. They're potentially non-technical stakeholders around the project. They are always free in DevOps, so they can add work items, which is great. They can query them. They can look at backlogs. They can get alerted, and they can provide feedback as well. Then you've got basic, which has all of that, but then you can do things like delivery plans, do Azure repos. They can commit to Git repositories and create them, um, and they can do more developer and more product focused actions across all the various different areas, if that makes sense. Um, and then you basically have basic plus test plans, because test plans is like another, because there's also hosted tooling there as well. So there's like another level on top of that to include test plans. And then you've also got an open source user, which effectively has access to everything. Um, it's just for public repositories at that point. So there's a couple of different ways you can license it. Um, you start off with a user license usually. So the basic plan is your five free users, and then your $6 a month, just like the open source extension plan. That gives you pipelines, boards, Azure repos, and artifacts. Um, so on top of your five, you then pay $6 per month. Um, but then you can basically extend that with test plans. So you add your basic, then you add your test plans on top. The cost then goes up quite dramatically, because when we're talking about test plans and management of test plans, that is a very sort of businessy, enterprisey sort of feature. Um, that then includes test plans. Um, so being able to do browser tests, client side test execution, planning those tests, tracking them, and providing feedback there, and also doing all the reporting of that. That is a straight $52 per month per user. So you go from, let's call it $6 a month. I know you get five free, but just ignore those for the moment. Um, that's another 40, what's that, $46 add-on for test plans. But you can get very, very, you've got hosted runners there with environments to be able to actually test even desktop software. So there's also a hosted element with that as well. Um, so when so that's sort of like the software, sort of the admin interface side of things. But then you've got separate pricing for Azure pipelines and Azure artifacts. So by default, you get one free hosted runner with Azure pipelines, which allows you to do one parallel job. So you can only do one thing at a time, and you get 1,800 minutes a month for free. So if you're on the basic plan, you also get that as well. So up to 5 users without test plans, you get one free Microsoft hosted runner. If you want to then go, um, you can promote that to a non-free runner, so unlimited minutes, and then you pay per parallel job that you want. So if you want two parallel, so two jobs that can run at the same time, probably going to be pretty good for a lot of teams. That's $40 per month per parallel job. So for two, you'd be charged $80 a month. Um, that's not for each environment or even each project. That's just, you can basically only run two parallel jobs at any one time for $80 a month. So you could be running two parallel jobs constantly for a month. So it's just really up to you how many builds you're doing and how quick you want those builds to execute. Because some builds can take potentially hours to build as well. So you might need extra capacity from that perspective. You can also do self-hosted pipelines as well. The first self-hosted pipeline that you each parallel, the first free parallel job is free. So you could have multiple runners locally, but you can only do one thing at a time. Basically, if you want to go to two, you pay $15 a month, and then you pay $15 a month on top of all of them going on. So you either pay Microsoft $40 or you host it yourself and still pay $15 a month. And that might not seem like a great deal, but they're handling, the actual running of the code and actually, sending it down and bringing it back up as well. So you do have to manage the operating system they're installed on, but in theory, you could have like bare metal performance of your builds as well, which could be pretty good. And the last thing just to talk about really is Azure Artifacts. Sorry, on the cloud side is Azure Artifacts. You get 2 gigabytes of artifacts for free, which for a lot of teams is pretty good. It depends how big your artifacts are and how many you want to keep in your feeds. You get a NuGet server, and you can support for npm and upstream sources. So basically the full feature set for up to 2 gigabytes, and then it's basically there's a sliding scale. So from 2 to 10 gigabytes, it's 2 gigabytes per month, uh, $2 per gigabyte per month. Then it drops to 1 gigabyte, and then it drops to no, it drops to $1, then half a dollar, and then and 25 cents, depending on how much you're actually storing. So it's like a sliding scale of a price consumption pricing there. That's cloud side. So it is a bit complicated because there's different ways to and different SKUs that you get with other services that are going on here. And then the DevOps server, there's basically two ways to buy it. There's a classic purchasing, so you can buy direct cows for DevOps server through Microsoft software resellers. So there's a new server license, and there's a cow for a single user as well. And then there's also a way to pay through Azure. So you can buy Visual Studio subscriptions, so Visual Studio Professional or Enterprise, or you could just go directly to um, to online DevOps as well. Was also a way to license it as well. So I believe that carries down like cloud licensing into on-prem licensing, if that makes sense. But you would be potentially wasting your resources in the cloud. So, but if you need the on-prem, then that would make sense for you.
Yeah. Okay. Cool. That sounds a lot there. And I think when I first looked at this, 3-4 years ago, because DevOps has been around quite some time now, I think, Azure DevOps. I think the basic plus test plan was the one that you could only get, I think, and they brought in this basic one, which gives you quite a lot. I thought there was only two plans, the stakeholders one, like you said, the free one, and then a paid one at one point, and it seemed quite expensive. So it looks like they've brought in this basic plan to help you.
I thought that you got it was stakeholder and basic, and then if I remember rightly, that test plans was always bundled in with Visual Studio. That's what I thought it was originally. But to be honest with you, I've mainly worked in teams that have just been stakeholder and basic, and unless because a lot of the time teams that I've worked in, the QAs and testers actually had their own software for tracking things, and we didn't need it, and a lot of it was done by hand anyway. So yeah, you can do a lot just with and basic. You get one hosted runner. You get all of the software free for up to 5 users, even in private. Right, that's still really powerful. Right, if you're open source, you get even more parallel jobs, which is really powerful as well. So even just basic, you get a huge amount of functionality in it for sure.
Cool. Okay, so we're definitely a long episode.
Oh, sorry everybody, we're up to an hour.
Yes.
Let's wrap this up.
Yeah, I was going to say, is there anything we've missed? But probably
No,
not.
I'm not. If we have missed it, yeah, it's absolutely fine to leave it out for sure. But yeah, there's a lot there, and we will dive into some of it in some separate episodes, definitely, to give you some more detail.
Cool. Okay, so next episode is going to be me being the SME, and I'm going to talk about. We're going to sort of finish off kind of the Windows 365 and Azure Virtual Desktop sort of campaign that we've kind of been going on. We did AVD sort of either the beginning of this season or just at the end of the last one, and we talked about Windows 365 a couple of weeks ago. So this is kind of doing a comparison against them, because there's definitely some. It's not to say pros and cons. They're just using different sort of scenarios, I think. So we're just going to run through that because I think it's worth doing.
Yeah, they're very similar tools, aren't they? And there's definitely a decision process there, and it's not a black and white process either, is it? So it'd be definitely good to get your thoughts on that for sure.
Yep.
If you've enjoyed this episode, please do consider subscribing if you'd like to listen to more of this sort of content in the future. We have many more topics that we like to cover, and your listens and support is what will continue to fuel the podcast going forward.
We also have the ability for you to give some feedback. Did you enjoy this episode? Disagree with our thoughts? Or is there anything that we missed? Please use the contact form in the show notes, or you can leave us a voice message on our website in the bottom right corner. There's a little button there. So, yeah, we'd love to hear from you.
Thanks, Alan, and catch you all in the next one.
Yep, thanks everyone. Speak to you next week. Bye.